Okay, Miss Scott, I see that you've joined us as well. How are you?
I'm good. How are you?
I am fantastic. Okay, so you got my email?
Yes.
Okay. Is there anyone else that cannot make it to class? I have the midterm set up from 10:55 to 1 p.m. because it's like you get 2 hours and 5 minutes for the midterm. Um, is there anyone that cannot make it tomorrow morning aside from Miss Phillips? Okay, well, all right. So everybody can make it. All right. So Miss Phillips, again, I'll have it set up starting at 7:55, and you will have from 7:55 to like 10:05. So you say you're only about 2 minutes away from your job, so you should be fine then.
I have a question though.
Okay.
So can we still use the 2 pages of notes that we wrote for the
Oh, most
retake?
definitely. Most definitely.
Okay.
Or if you
Okay.
want to, or if you want to make up some more notes, you can, since I'll be going over this review.
Okay. Awesome. Thank you.
Okay, no problem. All right, well, let me start back recording. Okay, so again, for this problem, number one, it says express 46% as a fraction or improper fraction. You could type 46 over 100, which is the equivalent of 46%. You could put that in your Desmos calculator, and it will give you this fractional counterpart here. Okay, and then you would write 23 divided by 50, or type it in on the exam. Okay, now number two, it says convert the following measurement to the specified measurement. So we have 21 centimeters is equal to blank meters. Now we know that going from centimeters to meters, that it takes 100 centimeters to equal 1 meter. So what you would have to do, wherever the decimal is in centimeters, and it's at the end here because it's 21, and any whole number you assume that a decimal is at the end. You will have to move it to the left because meters is larger than centimeters. So you will have to move this to the left 2 places. So 21 centimeters is equal to 0.21 meters. Now, it says here, number three, write the number in scientific notation. We have $7,766,000. Now we have to write this in scientific notation. Now to write this in scientific notation, remember you can only have one digit in front of the decimal. The decimal is assumed to be here, so we have to move this decimal to the left until we only get one digit in front of it that's not zero. So far we have 7.766. You don't have to write those last zeros. Then it would be times 10 to some power. Since we moved to the left, you will count how many places we moved to the left. We moved 1, 2, 3, 4, 5, 6 places to the left. So it'll be to the positive 6 power. Now, what I noticed that a lot of people make a mistake on when they do scientific notation, they do not check their answer. So if you're a little confused as to whether or not the exponent is supposed to be positive or negative, you could just check your answer by typing in 7.766 and then multiplying it by 10 to the 6th power. And then if it doesn't give you what the original number was, then you know you did something incorrect. So it gives us the original number. Now, if you would have put it as -6, it would have given you this number, and we know that number would be incorrect. So this is our scientific notation, the 7.766 times 10 to the 6. Okay, now we move on. we have here problem number 4. It says express 0.434 as a percent. So we have 0.434 and we want to make that a percent. Now, just to let you know, to change a decimal to a percent, there's a couple things you could do. You could just find where the decimal is and move it 2 places to the right. Write down the new number and put a percent sign behind it. That's one way of doing it. Or you could take that original number, multiply it by 100%. If you multiply this by 100% or 100, well, let me just put 100. If you multiply this by 100, we could put in our decimals calculator. We have 0.434 and then times 100. And that will give us 43.4, and we will put a percent sign at the end. Okay, now we move on to the next problem. All right, this is a percent decrease problem. Now, one thing I want to tell you is this here. Percent decrease and percent increase are done the same way. So I don't need to do a percent increase problem. What I do here for the percent decrease, you'll do the exact same thing for the percent increase. It says the sale price of a spring break vacation package was $199.99. And the travel agent said by booking early, you save $15. Find the percent decrease in price. Okay, so first of all, we need to know what the new value is. We need to know what the original value is. Those are the only two things we need to know. The original value, which is here, which was the original price, was the $199.99. The new price is $15 lower because if you were to save $15, that means you have to subtract $15 from here, which would be $184.99. Now, I will tell you this, a lot of times they would tell you what the new and what the original is, but this you had to do a little work. Now, the percent decrease, I'm going to put it as PD, I'm going to abbreviate it. Percent decrease is the new minus the original divided by the original. And that works percent increase or percent decrease. So the new value was $184.99 minus the original value, which is $199.99, divided by the original value, which is $199.99. Now, if you subtract these here, this will give you a negative 15 all over $199.99. So we will put this in our calculator. So we will have a negative 15 divided by 199.99. So this will give us a negative 0.075. We'll just round to 3 decimal places. But remember, it's percent decrease. So, or percent increase, you have to change this final answer to a percentage. So it'd be a negative 7.5%. Now listen, I have to tell you this because it is on the computer. Now you may encounter a situation where the answer will say that it had to have a blank and say decrease. So you would not write this negative sign. You would just write 7.5% because it's 7.5% decrease. Does everyone follow that? Okay, I'm going to take your silence as a yes. All right. Okay, so now, an increase would be the same way. All right, so now let's see. Number 6. This is dealing with sales price. It says a math book with an original price of $369.99 is on sale for 80% off. find the sales price. So if we have $369.99 and then it's 80% off. Now, you have to think about this here. They want to know just what the sales price is. Okay, so this is what we would need to do. If you paid the $369.99, that would be 100% of what the cost is. But they're telling you they're giving you 80% off. So we look at it like this here. 100% is the original value. They're giving you 80% off. So basically 20% is what you pay. So this would be the sales price. So what you need to do is take this $369.99 and multiply it by 0.20, and that will give you the sales price. Now, they did not ask you how much were you getting off. They want the actual price. So now we would take this value, this $369.99, and multiply it by 0.20, and then the sales price would be $74. It'll be approximate, because remember, we only go 2 decimal places. So that would be the sales price. Now, if they were asking you how much did you get off instead of the sales price, then you would take this $369.99 and multiply it by 0.80. That would tell you how much you actually saved. But this right here is what you would do to find out what the new price is, the sales price is. Okay, now let's look at number 7. It says a large chain store needs to assign 11 buyers up to its 5 stores. The standard divisor is 29.7, and the number of employees and standard quota for each store are shown below. Okay, determine how many buyers each store should receive using Jefferson's method. Okay, I'm going to let you all know right now, you're not going to use Jefferson's method. So don't worry about Jefferson's method. Okay, let me see. Okay, I'm going to do number 8. This is a percent increase problem. It says the class size at a certain school increased from 34 to 74. What was the percent increase? So 34 is the original. 74 is the new value. Now remember, I told you we do the same thing for percent increase as we did for percent decrease. We have new minus the original divided by the original. So percent increase, the new value is the 74. The original value is 34 and divided by 34. So this would be 40 divided by 34. We will go here and we will type in 40 divided by 34. Now we will round this to, we could round this to 3 decimal places. So it'll be 1.176. And so we will write that as 117.6%. That would be your percent increase, is 117.6%. All right. Now, okay, we did percent decrease already. Okay, let's look at this pie chart. It says the graph represents a survey of undergraduates enrolled in college in the 2003, okay, it was cut off the year, I think it was 2003-2004 school year. Approximately what percentage of students work more than 21 hours per week? So what I'm trying to get you to see here is how to read a graph. So when you look at this graph here, it says more than 21 hours per week. So we look here. So if it's more than 21 hours, we would only include these 2 values here, because these are the more than 21 hours. So for number 12, we would add those percents, the 21.4% plus the 18.6%. And when we add these, we would end up with 40%. So that's the percentage of students that work more than 21 hours. Okay, now we already did, I'll do a problem 13 real quick because we did it as a fraction. We want to change 37.5% as a decimal. So we would take 37.5, and since that was a percent, that'll be divided by 100, and Desmos gives us a decimal at 0.375. Okay, now number 14. It says a county has 3 districts. 4 representatives are to be appointed to the county board. The standard divisor is 128, and the standard quota for each district is shown below. Find the upper and lower quotas for each district, and B, determine how many representatives each district should receive using Hamilton's method. Okay, so let's take a look here. So I'm going to have to draw this real quick. We had the district. We had district 1, 2, and 3. I'm just going to draw some separator lines here. All right. The standard quota, I'm going to abbreviate as SQ. So the standard quota is 1.648, and then 1.523, and then 0.828. Now, they want us to do the upper and lower quotas. Okay, so now, they already did the standard quota for us, so we don't have to do that part. But we could do the lower quota and the upper quota. Okay, the lower quota, like I told you all before, the lower quota is always the number in front of the decimal. So this would be 1, 1, and 0. The upper quota is always 1 more than the lower quota. So that'll be 2, 2, and 1. Okay, so now they tell us here that we have 4 seats for these 3 districts. So we look at the lower quota first. When we add up the lower quota, that's only 2 seats. We need 2 more seats. So according to Hamilton's method, this is what we would do. We look behind the decimal of all of our standard quotas, and we would take the 2, since we need 2 seats, we would take the 2 highest values behind the decimal. And that would be this 828 and the 648. So it'll be District 1 and District 3. So what we would do when we're doing the seats, we'll write down seats here. The seats that we would choose with the 2 values that had the highest amount behind the decimal, we would take their upper quotas. The one that we did not change, we would still use is a lower quota. So the seats would be 2 for District 1, 1 for District 2, and 1 for District 3. And that gives you your 4 seats. And that is it. Okay, now we look here. It says 15. The graph shows the average daily reach for the 5 most visited sites on the internet for the 3-month period ending December 2nd, 2011. It says estimate the average daily reach for Yahoo. Okay, so if you look here at Yahoo, it's pink. So if we look here percentage-wise, the average daily reach is about, it looks about 23%. So 15 would be about 23%. So you could have did 22%, 23%, or even 24%. Okay, now, let's do 16. This is another scientific notation problem. Let's see, it's 6, 0, 1, 2, and a 3. Okay, so this is problem 16. we want to change this to scientific notation. So to change this to scientific notation, this is what we would do. We have to move this decimal until we get one digit in front of it that's not 0. So this would be 3.0 times 10. Now we have to determine the exponent. We move this 1, 2, 3, 4, 5, 6, 7 places. So we know our power is going to be 7. But we have to determine whether that 7 is going to be positive or negative. So this is where your Desmos calculator will come into play. So what we could do is type in what we have, 3.0 times 10, and we could take that to the 7th power. Now we notice that's not right because that's much larger than what our original number was. So then we would make this to the -7 power, and it actually gives us this in scientific notation. So let me see. Can I? No. Okay. It actually gives us this in scientific notation. So that would let us know, since the +7 didn't work, then that means that the -7 actually works. Okay, now we go here to 17. It says the hairs, let's see. Okay, this is basically a repeat of what we did with the problem 15. Let me see. 18 is the same. Let's look at 19. It says find 55% of 360 degrees. Now the word of means multiplication. So we'll multiply. We'll change this 55% to 0.55, and we'll multiply that by 360 degrees. So we'll take our Desmos calculator, and we would take our 0.55 and multiply by 360. So this would give us 198, and we'll put the degree symbol there. Okay, let's see. All right, let's look here at problem 21. It says the sales tax in Pennsylvania is 5%. If the tax on the item is $90, find the cost of the item. Let me see. No, 24 would actually be a better problem. It says find the sales tax and total cost of an item that costs $269.95 if the tax rate is 5.5%. Okay, so what they're asking us for problem number 24, they want us to find the sales tax. Okay, so and the total cost. So the cost of the item was $269.95. And they tell us the sales tax is 5.5%. So we'll multiply this by 0.055. That's the 5.5%. And then we will go right here to our calculator. And we'll take 269.95 multiplied by 0.055. Now remember, our money is only goes to 2 decimal places. So it'll be $14.85. That's how much the sales tax would be. Now, we want to find out the total cost as well. So to do the total cost, we'll take the original amount and add the sales tax to it. So we'll add the sales tax to it, which is $14.85. And the total cost would be $284.80. Because remember, our money goes to 2 decimal places. And that will be the total cost. All right, now, let's see here. All right. So now, It says here, this year, 10 faculty members are to receive promotions at a community college with 3 campuses. The number of promotions will be apportioned according to the number of full-time faculty members as shown. Find A, the standard divisor, and B, the standard quota for each district. Okay, so this is what we would do. The standard divisor is the total population divided by the number of seats here. So we would take the standard divisor is the total population divided by the number of seats. And in this case, it's talking about promotions, but it's still number of seats. So the total population, if you notice, is 410. And the total number of promotions or seats is 10. So the standard divisor is 41. So that would be your standard divisor. Now what they want us to give is the standard quota. Now this is why I was doing this problem, because in the other problem that we did, I think that was problem 14. When we did that problem, they gave us the standard quota, they gave us the standard divisor, and all we found was the lower quota and the upper quota. But with this problem here, we get to find the standard quota now. So the standard quota, so let me do this real quick. Campus, I'm going to do a quick chart here. The campus is South, Central, North, and then total. All right, so we have faculty, and then the South is 119, the Central is 140, and the North is 151 for a total of 410. And I'm going to separate these. Okay, now we want to do our standard quota, and I'm abbreviating it. Now what I'm going to do, I'm going to write this out as a fraction, and then I'm going to write out what the standard quota is. Now, on your test, you do not have to write out the fraction. You would just write out what the standard quota is. But this is how you get the standard quota. You take the district population and you divide it by the standard divisor. So this would be 119 over 41. This would be 140 over 41. And this here would be 151 over 41. So now we will put this in here. So we will have 119 divided by 41. And we could round to 2 decimal places. This would be 2.90. And then we could have 140 divided by 41. That would be 3.41. And then we could do 151 divided by 41. And that would be 3.68. And then from these values, you can get your lower quota, upper quota, and anything else you need to solve an apportionment. Okay, now, because they did not ask us, now they did tell us to round to 3 decimal places, but we'll just do the 2 here. But if they ask you for 3 decimal, matter of fact, let me go back. Let me do this proper. They said 3 decimal places, so this would be 3.683. And then we will go to 140. And then this will be 3.415. And then 119. This would be 2.902. Okay. All right, let's see. Okay. I don't think we did the reverse here. It says express 3.2 as a percent. Actually, we did do that, but we could do it one more time. 3.2 as a percent. We'll take 3.2 and we could either move it 2 places to the right, which would give us 320%, or we can multiply this by 100, and this will give us 320 and put a percent sign at the end. So either one is fine. Let's see. Okay, we don't have to do that. Okay, I want to do one more problem and then we'll move on to the second review. Now, I will tell you all this. If I do not finish this review while you all are on live, I will be sending this out as a YouTube video and it will be on Big Blue Button. So I will be sending you all a link if this is not done. Okay, so now we go here to problem 31. Now I want to slightly change problem 31. I know we have 5.75 times 10 to the negative fifth, but let's say we had 2.7 times 10 to the ninth power, and we were multiplying these two values. So what I would suggest first is that we go right here to our Desmos calculator and do our parentheses. We have 5.75 times 10 to the negative 5 power. And then we'll do another parenthesis, 2.7 times 10 to the ninth power. Now, what this does here is give us a total value of 155,250. Now, if we were asked to write our final answer in scientific notation, we were asked to multiply this and write this in scientific notation, we'll put our decimal here and move it 1, 2, 3, 4, 5 places. So it'll be 1.5525. We don't have to add that last zero, but if you want to, you can, times 10. Now remember, we move this decimal 1, 2, 3, 4, 5. So it'll be to the fifth power. And we could test it and see if it's positive to the fifth power or if it's negative. So it's 1.5525 times 10 to the fifth power. And it turns out that it's positive. So that would be our final answer. Okay, now this is the last of the first review. Now we need to go to the second review. Let me pull that up. That was the first review. I guess I might have made a mistake and got rid of it. Let me see. That I should not have done. Oh, maybe it's here. Let me take a look. Oh, there we go. All right, here we go. Right here. This is what. Okay, this is the second review for the chapter 2 portion. Now let me pull up the Desmos calculator. So I don't really believe we have much to go over for the second review, but let's take a look. Let me see. First of all, let's look at number 3. It says plot each of the following points on the same set of axes. Okay, we know this is the x-axis and this is the y-axis. So I'm just going to do one point, and you just have to pay attention here. We always stay at the origin. So, start at the origin. So we go 3, 5. So we'll go to the right 3, and then we will go up to y is 5. And this is where you will plot your point. And that's what you would do with all the rest. You only plot the point where y ends at. Okay, now, it says find the unit cost of 3 decimal places. Now, whenever they ask you to find unit cost, you're supposed to do the money first, ounces or whatever last. So if they want the unit cost, you would do the $6.49 and divide it by 12 ounces. So you'll put this in your calculator. So you have 6.49 divided by 12. And here they tell us to round to 3 decimal places. So this would end up being 0.541. And you would put the dollar sign, and then you would put divided by ounce. Or if you need to write it in words, it'd be 0.541 per ounce. So it's a little over 54 cents per ounce. Okay, now it says write the ratio in lowest terms. Now number 5, it'll be 10 meters divided by 2 meters. Now the meters will simplify each other out. 10 divided by 2 will give you 5/1. Now ratio is the only situation where you will leave the problem as a fraction. So it'd be 5/1. Ratio would be the only one that you would do that for. Okay, now it says write the rate as a unit rate rounded to the nearest hundredth. So now, again, they want us to ceramic tiles sell for $12.74 for a box of 12 tiles. Find the price per tile. So you would take the $12.74 divided by 12 tiles because they want the price per tile. So you would divide this out, 12.74 divided by 12. And I don't know if they told us to round to the nearest hundredth, so that's 2 places. So it'd be $1.06 per tile, or $1.06 per tile. All right. Problem 7. It says, what type of growth is shown in the table below? Linear, exponential, or neither? Okay, now, and then they ask you if the growth is linear or exponential, then find the next 3 values. Okay, listen. I got to move this Desmos calculator over because you need to be able to see this here. Hold on, let me see if I can. All right. Okay, good. All right, now, this is what we would need to do. We would need to add a table. Okay, so now A is your X value and B is your Y value. So start is actually 0. So we'll put 0, then 1, 2, 3, 4, and 5 months. We don't need that 6 months. Okay, now we will put in the values. We have 50, 53.50, 57.50, 63.50, 71.50, and 74. Okay, now your next thing, you will click this magnifying glass. Matter of fact, you could click the minus here so you can see this. This is almost, it almost looks like it could be a straight line or it could be exponential. So what we would have to do is check this out. So how you check this, first you would do the slope-intercept form, which is a linear equation. You'll go to the keypad and you'll put y, then the y1, because remember in our table here is y1. Then we'll hit the tilde symbol, and then you will do mx1, and then you will do plus, and then b. Now we see here, this almost looks almost perfect. But let's take a look at the exponential. So we have y1, the tilde, it'll be AB, to the x1 power. And then you have to click on log mode. Now, what you do here to see, now we see that one of these graphs actually works, so it wouldn't be neither. So one of these graphs actually work. So we would look at the correlation coefficient. Remember, the correlation coefficient is R. And whichever one is closest to +1 or -1 is the better graph. So if you know R is equal to 0.9899, R is equal to 0.9927. So the exponential is actually the one that we need. So for that problem, we will put down exponential, and we will put down, they also want us to find the next three values. So to find the next three values, all you would need to do is this here. You can write out the equation. Let me write out the equation. The equation would be y is equal to, and if you notice here, we're in 2 decimal places, so we'll do that here. It'll be 49.51 times 1.09 to the x power. Now, I'm going to move this back over here. Now they want us to do the next three values. This is our equation from what we got here, because we use the exponential. So we would type in 49.51 times the parenthesis 1.09, and then we would take this to the 6th power because they want the next three values. So one value would be $83.03, and then we could change that 6 to a 7, and then the next value will be $90.51, and then change that 7 to an 8. And then we have our next three values, $98.65. So these were the next three values. Now, let's see. Number 8. It says the equation y equals 81.6 times 1.013 to the x can be used to model the population of a country and millions of people based on the number of years since 1900. Identify the variables in this equation. Now, this is really good. So, if you notice, this equation here is in exponential form. Okay, now, this right here is our A. This right here is our B. And we know X is our X, because the general formula is y equals AB to the X. So let me tell you what each one of these mean. A is equal to the y-intercept, or the beginning amount. B is equal to the growth factor. And then you could put as a side note, the growth rate is the growth factor minus 1. Now, X is the time. So that's what each one of these means. Now, the Y is just basically your solution to the problem. But all the rest of these, A is the y-intercept or the beginning amount. B is the growth factor. If you just want the growth factor, you will write B as is. But then if you want the growth rate, you have to take this and subtract 1. And then the time is X. Okay, now let's see here. Number 10. It says for one particular data set, both a line and the exponential equation of best fit are found. For the line, the value of R is 0.403, and for the exponential, the value of R is 0.977. Which type of equation is most likely the better choice for the data? And we know the value that's closest, the value of r that's closest to 1 is the better one. So it'll be the exponential. So for number 10, it'll be exponential. And then you could put as an explanation higher R value. And we know R is equal to correlation coefficient. Okay, now 11 we're going to skip for now. Let me see. 12, 13, no. Okay, we're going to go to 14. It says radioactive elements are good examples of substances that decay exponentially. Iodine 123 decays in such a way that 95% of the initial sample remains after each 1 hour period. If an initial sample is 240 milligrams, write an equation that describes the amount remaining after X hours. Now, they tell us that 240 milligrams is the initial amount. Okay, so now, and it tells us here that this decays at 95%. So it's 95% decay factor. Well, 95% is equal to the decay factor. So now, and they say X is equal to our time, which is in hours. Okay, so now we'll write this as an equation. So as Y equals, we know the initial amount is A. So that'll be 240. The decay factor is what we put in the parenthesis. We don't put rates in the parenthesis, we put the factors. So it'd be 0.95. That's the decay factor. And then finally, we'll take it to the X, and that would be the time. Okay, let's see. Let me see the table below. Okay, now, here's the thing. Let's go back here to Desmos. Now, remember how we went through this table here. We did the table of values, and then we used these formulas here to find the linear regression and also the exponential regression. And we settled on the fact that it was exponential and that we used the equation. So we would have y is equal to, the A would be 49.51, the B would be 1.09. Now, if we wrote this, as a matter of fact, let me write this out. If we were to write both of these formulas that we have here, this would have been y is equal to 49.51 times 1.09 to the x value. This would be the exponential. The linear, which we did here, the linear we look at m and b is y equals the m rounded to 2 decimal places would be 5.14x, and then the b is positive, so it'd be plus 48.81. So the reason why I did it like this is because we already have this set up. And one other thing, remember, when you're doing exponential, you always got to click on log mode. Okay, the reason why I did this is because for 18, they're asking you to do that. Now here, disregard these, well, with these years, your first year is your 0 year. And you would do years since your first year. That's how they got 0, 2, 4, 6, 8, 10, 12. So that would be your X. Your Y is the number of women. You would put it into Desmos, and then you would do what I showed you here. For the linear, you will put that y1, the tilde mx1 plus b. For the exponential, you will put y1 tilde ab to the x1 power. And then that will give you both equations. And then it tells you to decide which model is the better fit. You'll look at their R value. Whichever one has the closest R value to 1 or -1 would be the better fit. Now we look here at 19. It says, would a linear model or exponential model be a better choice? You notice here to be the exponential model would be the better choice. Okay, let's see. How far does this go down? I think it goes down to 41. Okay, we have basically ran out of time, but I am going to finish this video in a few minutes. Now, if some of you all want to stay on as I go through this after class, feel free. But I'm going to need you to hold on for just a second, and I'm going to go through, I think I only have about 5 or 6 more problems to go, and then I will be done with this review. So just hold on. And I'm going to pause the recording and I'm going to mute because I got to get to my other class. Okay, class, just reviewing back on 19 because I had to take a pause here. On problem 19, it says, would a linear model or exponential model be a better choice? And if you look here at problem 19 is set up like an exponential model with this curve, exponential growth. So an exponential model would be a better choice here. Okay, now 21. It says find the slope and y-intercept. Now with 21, this is in the form of y equals mx plus b. So this y equals 18x minus 43. M is the slope, and then this negative 43 will be your b or your y-intercept. So they ask you to find the slope. So you could put down m is equal to 18. And then you could put down b is equal to a negative 43, or you could put this as 0, negative 43. Either one should be fine. Okay, now look here. It says the table below lists the average tuition cost for all public American colleges and universities for a variety of school years starting in 1981. It says using a graphing calculator, you find the exponential equation of best fit for your graph to be y equals 2,757.0 times 1.0566 to the x. Write a description of what the base of the exponential in your exponential model says about the growth of tuition since 1981. So what they're asking you here, you do not have to put this in your calculator. They gave you the formula. And now they want you to interpret a part of the formula. They want us to do the base. B is your base or growth factor. So in this would be your B. Oh, I'm supposed to put y equals. This is your B. We know this is our A, and we know this is our X. B is also called the base and the growth factor. So what they want to do, they want you to tell about the growth of the tuition since 1981. So since they're talking about the growth of tuition, they're not talking about the growth factor. They want the growth rate. So you would take this 1.0566 and subtract 1 from it, and it'll give you 0.0566. And then you have to change this to a percent. So it'd be 5.66%. So when you write your explanation, you could say tuition goes up 5.66% each year since 1981. Now, I want to stress something else to you all. Since we didn't need this table, I had no reason to show you the full table. But if you did need to use this table to put in your calculator, remember, 1981 would be 0 because you're going to change these dates to reflect that everything is since 1981. So this would be 0. This would be 10 years past that. This would be 20 years past that. Then you add 21, 22, 23, and so on. The cost would not change, But when you're typing this into your calculator, you do these dates since the first value or since the value they give you in the directions. Okay, now it says what type of growth is shown in the table below. We already did a problem like that. Now it says here the equation y equals 81 times 1.013 to the x illustrates blank growth. We know this is exponential growth because this is the same as y is equal to ab to the x. So for 25, it'll be exponential growth. Now it says here, classify the pattern as either linear or exponential growth. So we have 1, 2, 4, 8. So if you notice here, first thing I will always suggest is to add or subtract to see if you get these values. So if we added 1 to this one, that would give us 2. But adding 1 to 2 would give us 3. So we know linear is gone. Now we're going to try exponential. Exponential deals with multiplication or division. Oh, and we didn't have to do subtraction because the values are not going down. That's why we just did addition. So look, if we said 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, so we know it's exponential. So that was 26. 27, it says classify the pattern as either linear or exponential. Now we see this is going up, so we'll try addition first. If we add 16, that'll give us 816. Add another 16, that would not give us 832.32. So now we have to try exponential. Now, if you want to try exponential, this is what you could do. You could take the second value divided by the first value, 816 divided by 800, and then take the third value divided by the second value, 832.32 divided by 816, and then I would take this fourth value divided by the third value. So it'd be 848.9664 all over 832.32. Now we will put this in Desmos to see if it would give us the same values. So we had 816 divided by 800. It gave us 1.02. We had 832.32 divided by 816. That'll give us 1.02. Then 848.9664 divided by 832.32, and it gives us 1.02. Now, I will tell you, if this went further, so this would be exponential. But if this went further, and you got an answer that was like say you got an answer that was 1.019 or something, that would be acceptable as 1.02. If it's something very close, you could use that as well. Okay, now we did a problem like this here already. Okay, look here. It says the growth rate of y equals 80.25 times 1.014 to the x, where x in years is blank percent per year. Now remember, with growth rate, we would take our growth factor. This is problem 30. Our growth factor was 1.012. And then we would have to subtract 1 from it. So it'd be 0.012. Then we would change that to a percent, move this 2 places to the right. So it'd be 1.2%. And you know what? I actually wrote down the wrong problem, but it's still, I actually was doing problem 29. So we would still do the same thing I did here, except for this 2 would be a 4. So it'd be 1.4%. This was actually 29. Okay, 30. It says the equation y equals 81.15 times 1.012 to the x can be used to model the population of a country and millions of people based on the number of years since 1900. what is the significance of the parameter 81.15 in this equation in terms of the population? So first of all, we know in problem 30, this is written as y equals ab to the x. Okay, that's the first thing. The second thing is we know that A is the initial amount or the starting point. So 81.15 is actually the starting point here. So 81.15, and we will put million, is the population, and it tells us that 1900 was our starting point. So 81.15 million is the population in 1900 because this is supposed to be in millions. So 81.15 million in 1900 because that is the starting amount. Now, okay, 32. Okay, we did this. Elaine keeps an investment. What does the line picture below have? Positive, negative, or zero slope? Let's see. No. I'm looking here at problems that we've already covered. Okay. So let me do, I think it's only 2 more problems I need to do, and then we would be done. Okay, 32. A lemonade stand serves several beverages in different sizes, and each contain different amounts of sugar. Determine which of the beverages contain the greatest amount of sugar per fluid ounce and indicate the amount. Now, they want us to do sugar per fluid ounce. So sugar will go first, and then the fluid ounces will go second. So for 32, we will have 66 over 21. And I could write the ounces. So it'd be 66 grams over 21 ounces. That's the lemonade. 61 grams over 15 ounces. And then 40 grams over 13 ounces. And then 32 grams over 9 ounces. Okay. Renee, do you have a question? Renee? Okay,
No, I do not.
okay,
Sorry.
okay, thank you. All right, so now we put these values in our calculator. So we would have 66 divided by 21. Let me see, what did they tell us to round to? 2 decimal places. Okay, so for the first value to be 3.14. Second value we have 61 divided by 15. That'll be 4.07. The third value is 40 divided by 13. That'll be 3.08. And then finally, 32 divided by 9. That'll be 3.56. So it's the second amount. So the one that has the most sugar per ounce would be the fruit punch. So the fruit punch. Now, the next problem that I wanted you to take a look at was actually it's actually a mixture. I want to do 39. I was going to use 40, but let me do 39. Okay, listen. It says determine the slope by using the slope formula at any 2 points on the line. Now, what I want to do here, I want to show you how to do this in Desmos. We're going to pick 2 points on the line. One point is here at 0, 1. This is 39. We'll use 0, 1. And then another point, it hits exactly here, which is -1, -1. Now, with just 2 points, you can use Desmos to find not only the slope, but you can also find an equation for it. So we would add a table. Now, if you notice, this table says x3 and y3. And what we would do here, we would substitute in these values. So we had 0 for x, and then we had 1 for x. And then we have 1 for y, and then we will have -1 for y. Okay, now we have to do our tilde, the y, and then it'll be y3, because remember, this set has 3 with it. And then we would do the tilde, and then we would do mx3 plus b. And then now it gives us the slope, which is -2. So that would answer number 39. The slope would be -2. But if I wanted you all to write this as an equation, you would put y is equal to -2x plus 1, because it gives us the slope and the y-intercept. And this is how you would do the equation. And then here is the correlation coefficient, and it's -1. That means that this is a perfect line. Whenever you have 1 or -1, that means that it is perfect. Okay, now, there was one other problem that I told you that we would come back to. I think it was, no, it wasn't 20, was it 24? I believe, oh no, it was, yeah, I think it was 24, but we actually did that earlier. We actually did problem 24. It's the same way, and I'm going back here. It's the same way we did problem number 7. So 24 is the same way we did problem number 7. So we are actually done with this review.